You ever feel stuck at a crossroads? You know, when a big choice just feels paralyzing? But what if you had a systematic way to figure it all out? Well, in this explainer, we're going to break down the actual science of decision making. We're going to give you a toolkit of models to help you find the best path forward, no matter how complicated things seem. So let's dive in. I mean, think about it. From what you're going to have for lunch to a huge career move, we are just constantly making decisions. And most of the time, we kind of use our intuition, right? But when the stakes are really high and the future is foggy, just going with your gut, well, it often just isn't enough. We need a more structured way to think about it. And that's exactly where decision theory comes in. Now, it's not magic. It's a real field of study that gives us frameworks for making the best possible choice. It's this really cool mix of mathematical analysis, psychological insights into our own biases, and even economic principles for weighing all the different outcomes. So today, we're going to go on a little journey across what you might call the information spectrum. We're going to start in total darkness, where we know pretty much nothing. Then we'll move into situations where we can actually calculate the odds. After that, we'll see what happens when we're facing off against competitors. And finally, we'll land in a place where the future is perfectly clear. Ready? Let's get started. Okay, our first stop is decision-making under uncertainty. This is the big one. This is for those situations where you have options, but you have absolutely no data, no past experience, nothing to tell you the likelihood of any particular outcome. The crucial point here, the thing you really have to remember, is the complete absence of probabilities. Just imagine you're launching a product that is totally unlike anything else on the market, or maybe you're investing in some brand new, unproven technology. You can picture the outcomes, sure, massive success, maybe modest growth, or total failure, but you have no real data to assign a percentage chance to any of them. You're flying blind. So, without data, your choice really depends entirely on your strategy for handling that risk. You kind of have to adopt a persona. So, are you going to be the optimist using the max strategy to chase the absolute highest possible reward? Or maybe you're the conservative using maximin to brace for the worst case scenario. Each of these gives you a logical path forward, but it's all based on your mindset. Okay, now let's step out of that darkness and into a world where we have a little bit of light to guide us. Our next model is all about decision-making under risk. And this is where the game completely changes. The defining feature of risk is that we can actually assign probabilities to future events. This could be based on years of sales data, or weather patterns, or maybe just an expert's informed judgment. The point is, we're no longer just guessing, we're calculating. So just to make it super clear, here's the key difference. Uncertainty relies on your strategic mindset, your persona. Risk, on the other hand, relies on objective math. That shift from uncertainty to risk is a huge one. It's a move from pure judgment to data-driven analysis. Now, to handle all this data, you need the right tools. And one of the most powerful ones is the decision tree. It's basically a flowchart that lets you visually map out every possible choice, every potential outcome, and all the probabilities connecting them. It's amazing for untangling really complex multi-step decisions. I love this quote because it just hits the nail on the head. A simple table might show you the final numbers, the payoffs, but the tree shows you the journey. It lets you see the whole chain reaction of your choices, showing exactly how one decision flows into the next set of possibilities. It's the process that matters. So far, we've basically been dealing with states of nature, things like market conditions or the weather. But what happens when the outcome isn't determined by chance, but by a thinking, rational opponent? Well, this brings us to decision-making under conflict. In this environment, success isn't just about you. It's more like a strategic dance. The outcome of your choice depends entirely on the choice your competitor makes, and their choice depends on yours. You're not just forecasting the market anymore. You're trying to outthink an opponent. And the formal framework for all of this is called game theory. It's basically the science of strategy. It analyzes how rational players should behave in situations of both conflict and cooperation. And it's used absolutely everywhere, from business pricing wars to international politics. All right, let's look at the most famous example of all time, the prisoner's dilemma. So two partners in crime are being questioned separately. Think about your options here. If your partner stays silent, it's actually better for you to betray them so you go free. Now, what if your partner betrays you? Well, it's still better for you to betray them too, so you get a reduced sentence of 2 years instead of 3. So from a purely individual, rational perspective, betraying them is always the safer bet. And that's the paradox, isn't it? Because betrayal is the rational choice for both people. They both end up betraying each other, and they both get a worse outcome than if they had just cooperated. This same exact logic drives things like destructive price wars, where companies just keep undercutting each other until profits completely disappear for everyone. It's a lose-lose. We've navigated the darkness, we've calculated the odds, and we've faced our opponents. And now we've arrived at the final stop on our journey, the rare but incredibly powerful state of decision-making under certainty. I mean, can you imagine knowing with 100% confidence the outcome of every single choice you could possibly make? That's what decision-making under certainty is. The consequences of every alternative are known in advance. There are no probabilities, no surprises, nothing. So the challenge here completely shifts. It's no longer about prediction, it's all about optimization. Since you already know every outcome, your whole task is to systematically find the single best path, the one that maximizes whatever you want, like profit, or minimizes something you don't, like cost. And the primary tool for this job is something called linear programming. It's a mathematical method for solving these super complex resource allocation problems. So, for example, a factory can use it to find the perfect mix of products to make, given that they have limited raw materials, labor, and machine time. Linear programming crunches the numbers and just gives you the single best answer. So we've traveled all the way from complete uncertainty to perfect certainty. Let's pull it all together now and see how you can choose the right framework for your own decisions. This right here, this is your decision-making cheat sheet. It neatly summarizes all 4 models. So if you have no probabilities, you're in the world of uncertainty, and the key question is all about your attitude toward risk. If you do have probabilities, you're dealing with risk, and you're calculating expected outcomes. Facing a competitor, that's conflict. And if all the outcomes are known, it's a certainty problem, and you're focused on optimization. Ultimately, it all boils down to this one simple thing. Choosing the right decision model isn't about which one is best. It's about being honest and accurately assessing how much information you actually have. The amount you know about the future is what dictates the tools you can use. It's that simple. By understanding these frameworks, you can move from just guessing to making structured, rational choices. You can identify what you know, what you don't, and then apply the right strategy for the situation. So the next time you find yourself at a crossroads, you'll have more than just a gut feeling. You'll have a map.